Hi, I'm Steve Ingrassia. I'm currently the Algebra 2 honors teacher here at Hawken, and I'd like to go over a problem for you that's typical of the types of things that we have our students work on during the year. Here's the challenge I gave my students. Suppose you've decided to build a pyramid of coelacanths. First level of the pyramid has exactly one coelacanth in it. The second level of the pyramid has 4 more. The third level has 9 more, and so on. Can you come up with a function that will tell you how many coelacanths there are total given the number of levels? And then, once you have that function, can you use it to answer questions about similar pyramids? So here's how students might get started. We had several students that were able to solve this. I don't have video recordings of their solution, but this is sort of the reasoning that they went through. Okay, when I've got one level, then the number of coelacanths was 1. When I've got 2 levels, the number of coelacanths was this 1 plus 4 more. That's 5. When I've got 3, I've got the 1 and the 4 plus 9 more. That's 5 plus 9, or 14. When I add a 4th level, I've got the 14 I had from the first 3 plus 16 more. That's 30, and so on. And my students were all convinced that given enough time, if I asked a question, how many coelacanths are there in a display with 6 levels, or 7 levels, or 12 levels, or 18 levels, or 100 levels, they'd be able to figure out the answer by going one at a time. I challenged them to go a little further. Can you come up with a function that, given the number of levels, returns the number of cans? So let's say we called that function cans of level. We want to be able to say that cans of 1 equals 1, cans of 2 equals 5, cans of 3 equals 14, and so on. So my students didn't know how to approach this analytically and come up with an exact answer, but they know an awful lot about trying to get their Inspire calculators to try and build regression equations for them. So they went over into the Inspire. Let me open up the Inspire right now. And they said, let's create lists and spreadsheet data, where I'm going to call this one the number of levels, and I'm going to call this the number of cans. And remember, we had, when there was 1 level, there was 1 can. When there were 2 levels, there were 5 cans. When there were 3 levels, there were 14 cans. When there were 4 levels, there were 30 cans. And some of the students may have put in more rows than this, but this gives you an idea of what's happening. Okay, looking at those numbers right there doesn't give me any more insight than I had by writing them down by hand on the previous screen. So let's see if we can get a visual on it. I'm going to go into, let's see, I'll go into a data and statistics page. And for my independent variable, I'm going to pick the number of levels. And for my dependent variable, I'm going to pick the number of cans. All right, well, now I see some sort of pattern. They're certainly increasing. I wonder how they're increasing. Clearly, a straight line isn't going to be my best bet for a function here, because, a straight line that connects this dot with this dot would not get nearly high enough for the next ones. But maybe a polynomial of higher order would work. Let's try a polynomial of higher order. So we're going to analyze this graph, choose regression, and pick a quadratic regression. Doesn't look too bad, does it? It fits these 4 points in just fine. Looks like it's got them almost exact. Let's find out how exact it is. Let's look at our r squared variable. In order to do that, I'm going to go over to a calculator page, look at my variables, and pick the stat r squared variable. It says 0.999598. Pretty darn good fit. That's a pretty good fit. I wonder what the equation is for this. Well, I can print out the regression equation. The regression equation, when I put an x in, is 3x squared minus 5.4 times x. I'm going to dismiss this. Minus 5.4 times x plus 3.5. So maybe that's a good equation to use. Let's see what happens if I use it to try and predict how many cans there will be if I put in 5 levels. So I will do stat.regression equation and give it a 5. It says 51.5 cans. I'm pretty sure that's not an exact answer, because I'm pretty sure I'm not going to ever have a pyramid with half a can. Let's try another one. Stat.regression equation with 6. 79.1 cans. Yeah, I got an equation that worked pretty well for the 4 data points I gave it, but maybe it's not quite so good overall. So let's try a different regression. I'm going to go back to this place where I've got my 4 points and I've got this regression equation. I'm going to try a different one. Instead of analyzing it with a quadratic regression, let's try a cubic regression. It's this one here. It goes right through the center of that point, right through the center of that point, right through the center of that point, right through the center of that point. And here's my equation. About 1/3 times x cubed plus 1/2 times x squared plus 1/6 times x plus 0.000000004. Pretty much plus almost nothing. Let's see how good that equation is. I am going to go back to my calculator page and look at my r squared value. R squared value of 1. That's even better than 0.999. Let's see what this regression equation was. Stat.regression equation of x was this. Let's see what I get when I try and put in a 5. 55. That's looking better than 51.5, isn't it? Let's see what happens when I try and put in a 6. 91. We're looking pretty good here. Is 55 the answer I would have expected? Let's go back and try it analytically. If I added one more level to the pyramid here I've got 1, 4, 9, 16. I'd be adding 25 more. What's 25 more than 30? I should get a 55. Is that what I got? That's exactly what I got. If I add 36 more than that, that should be what happens when I get 6. What's 55 plus 36? Well, no need to do it in our head. We've got a calculator here. 55 plus 36 is 91. I think we've found a winner. We've got a good equation that seems to be working very well for us. Now that we've got that equation, let's take our model out for a spin and see what sort of questions we can ask. Now that I know I've got an equation that if I give it the number of levels, it gives me the number of cans. Let's say I want to build a pyramid that is going to impress all of my friends at a party that I'm giving. So build a pyramid that will impress friends by being 6 feet tall. How many cans do I need? Now, how do I solve this? How do I solve building a pyramid that will impress friends by being 6 feet tall? Well, first of all, I've got to figure out how many levels in 6 feet. If I've got a pyramid that consists of this, one level, another level, another level, another level, and I know all of this is 6 feet, I've got to decide how many levels that is. So, we measured how tall a can of cola was, and we got 1 can equals 4 3/4 inches. So each level is 4 3/4 inches. If I'm 6 feet tall in my pyramid, how tall is that in inches? The pyramid equals 6 feet times 12 inches in a foot. So let's make this 6 feet times 12 inches in a foot equals 72 inches. So how many levels do I need to be at least 6 feet tall? The levels equals whatever 72 divided by 4.75 is. I can't do that one in my head. I'm going to let my calculator help me out. So I'm going to say, what is 72 divided by 4.75? And it says you need 15.15 levels. Well, I can't do 0.15 of a level. If I cut a can so that it's only 0.15 of its height, all of the Coke will spill out. So let's go to 16 levels. How many cans do I need for 16? I've got my equation. I do stat.regression equation. Let's see, stat.regression equation. Pass it in a 16. And I get I need 1,496 cans. I don't buy cans individually. I buy them in 12 packs. How many 12 packs is this? 1,496 divided by 12. Okay, it's telling me that's 374 divided by 3 packs. I would rather know that in decimal form, so I'll do Control-Enter. It says 124.667. I'm going to need to buy 125 12 packs for my display. How much does a 12 pack cost? Let's look up an ad. Giant Eagle is selling them for $3 a 12 pack. So I need 125 12 packs times $3. That's $375 to do my really impressive display. I will then have 1,496 cans of cola that hopefully all of my partygoers will be able to drink, because I don't want that many left over. Okay, there was an example of coming up with an equation, using that equation to answer some questions about what we were modeling to begin with. That's the type of thing you'll do in Algebra 2 Honors. Thanks. Enjoy the rest of your day here at the Open House.